Blockchain technology is changing the way that we use the internet today, from the tokenization of real-world assets to on-chain digital identity and digital anonymity. Today, we're going to go over the basics of Solidity and how you can get started with writing your very first smart contract today. My name's Anthony. I'm with the Blockchain Dojo, where we turn you into a blockchain ninja and a Solidity expert. If you like what you watch, please like and subscribe for more content. Let's get started, guys. Today's video, we're going to be going over the basics of Solidity and how to write your very first smart contract. We're going to be going over both primitive and complex data types, functions, constructors, modifiers, and events. First thing we're going to be going over in this smart contract is variables, and primitives specifically. Solidity, you have quite a few variable types. You have address, which is used to store the hexadecimal representation of the public addresses. You have strings, and you have uints as well as bytes. These are your standard primitive data types, which can be used to create more complex data types. There's also enums, which is enumerators. Essentially what that is a numeric representation of a value, which can be changed and updated throughout the context. On top of primitive data types, we also have the structs, which is the ability to create your own data type, meshing together multiple different types of primitive data types as well as other complex data types as well. Included in that, we also have mappings. What a mapping is a key value pair, essentially storing a unique key to an individual value or values. You do have the ability to map nested mappings as well as mappings to arrays. Along with all those variable types, we also have events. Events are a form of cheap storage in which you can index and store data onto the blockchain cheaply, but also in a way that other dApps and applications can respond and interact with. Essentially what an event is it's sending out a signal to other blockchain developers, applications, and things along those lines. In Solidity, there's also something called a modifier. A modifier is a check or balance which is run before a specific contract function is run. So essentially when we have this live contract modifier, what it does is it runs this, we attach it to a contract, it runs this require statement, then this symbol here triggers the running of the remainder of the function. Right down here in the update string, you can see the live contract modifier being added to the function, which essentially needs to meet this condition right here for the function to run. Specific to this modifier, we are using a pause and unpause contract functions. This is used to pause and unpause the contract using the contract status enum. Essentially what this says is if the contract is paused, these functions with the live contract modifier cannot be called. Up next, we have the constructor. The constructor is a unique function that is only run once when the contract is deployed. You cannot randomly call this constructor, and you cannot call it after the contract is deployed. Upon deploying the contract is when this code block is executed and when this code block is executed only. In this constructor, as you can see, we're setting a number of variables, including the starting storage string, we're turning the status of the contract to live, and we're setting the owner of the contract to the message.sender, which essentially means the person who deployed this smart contract. In Solidity, there are two types of functions. You have functions that modify the blockchain state and functions that read the blockchain state. They're essentially determined based on this modifier, this keyword right here, view. If a function is a viewable function, it only reads from the blockchain, while functions without that modifier write to the blockchain. So specifically, we can take a look at the set user variable function here. What this does is this takes in a new string and then an arbitrary value or amount. This is just to show the complex storage type, complex data type. It is a public function. Public function means that it can be called from both internal or external, meaning this contract itself, externally owned addresses, externally owned contracts, as well as contracts that inherit from this contract. And then it also has the live contract modifier. What this does is it creates a new storage struct, taking in the new string and the amount, storing it in the user storage struct, It then maps the user storage variable of message.sender to the new storage that we just created in memory. And then it emits a storage update event. This event can be listened to as mentioned by other blockchains. There is another keyword I'd like to go over here, memory. There's three storage types technically. There's memory, storage, and call data. What memory does is it's more like RAM for a computer, meaning it's stored temporarily and wiped when the function is clean. Storage is written to the blockchain, so it's a little bit slower and uses more gas. Get user storage takes in a user address. It's a public function, meaning it can be called within and without the contract or outside of the contract. It has the view modifier or restrictor, meaning that it only reads from the blockchain, and it will return a user storage struct from memory. As you can see here, what we do is we call the user storage mapping, passing in the user address, which returns the struct for that specific user. So what this contract does specifically is it stores a main storage string variable for the entire contract, as well as each individual address can store its own specific storage string and amount. How a user is able to update the main storage string is by calling the update string function while the contract is unpaused, passing in a new string in memory, which then increases the number of updates, changes the storage string to be equal to the new string passed in, and then emits a storage updated event. In order for someone to delete the string, we're not actually deleting the string completely, as we are just setting it to a empty string value, which then emits the same storage updated function. We also have a get storage string, which is a public view function, which returns a string in memory, which once again returns the string. The other functionality of this contract is users are able to set their own specific user storage struct, and they're able to actually store their own strings and arbitrary number. They're able to do this by calling the set user variable, by passing in a new string and then the arbitrary amount variable while the contract is unpaused. We then, as mentioned prior, we create a new storage variable, which is a user storage struct, and then store it into the mapping. For this one, we are actually going to be deleting the user storage mapping, what we do is we pass in the message.sender's address into the user's storage mapping and delete it, and then emit storage updated message.sender and empty string. The final function here is the get user storage function, which is a public view function that returns a user's storage struct from memory. And then once again, we just pass in the user's address into the user's storage mapping. This is a rough profile contract that I've written just to show you how to utilize actual structs, mappings, and variable types, as well as functions. So in this profiles contract, what this is essentially like a social media profile, which users can come in and create their own profile with their own username and set their own status. So first we have the address, which is a public variable storing the owner, which is set in the constructor as the message.sender or the deployer. We have a mapping of addresses to a profile struct, and it's a public mapping labeled profiles. Next, we have the profile struct, which includes the profile address, the username, and the status. A function here is the create profile, which takes in a string in memory called username and a string in memory status. We have a require statement or a check. What this does is ensures that the profile of the message.sender has not already been created. If the profile has been already created, it reverts the transaction. Next, what it does is it updates and returns the profile struct for the message.sender, passing in the message.sender address, the username, and the status. Next, we have another function just updating the status message, which what this does is it requires, again, that the profile was created, and then it updates the profile of the message.sender's status to the new status passed in memory in the function here. Thank you to everyone who stayed to the end. I hope you learned something new. This is a high-level overview of the Solidity Smart Contract Programming language, data types, functions, modifiers, events, enums, constructors, pretty much all the basics you need to get started writing your very first smart contract. In the next video in this series, what we'll be doing is going over how to actually test smart contracts after they're written or while you're writing them, ensuring that you receive the proper output for the functions that you're calling. Once again, thanks for everybody who's watching. If you learned something new, like I said, please like and subscribe, and stay tuned for more content.